I've always been fascinated by the bizarre world of the infinitesimally small. But what exactly is small? And how small can things get before the laws of physics as we know them break? Welcome to the mind-bending realm of quantum physics, where particles can be in two places at once, where uncertainty reigns supreme, and where our intuitions about reality are turned upside down. Are you ready to dive into the quantum rabbit hole? What is quantum physics? It's the study of matter and energy at the tiniest scales imaginable. And when we zoom in that close, the universe starts to behave weird. Really weird. In the early 20th century, scientists realized that classical physics just couldn't explain what was happening at the atomic level. Why? Enter quantum theory. It all started with a puzzle: the ultraviolet catastrophe. Max Planck solved this by proposing that energy comes in discrete packets, or quanta. This was just the beginning of a revolution that would change our understanding of reality itself. Now let's talk about wave-particle duality. Is light a wave or a particle? The answer is yes, both, or neither. It depends on how you look at it. In fact, all matter and energy exhibit this dual nature. This leads us to Heisenberg's uncertainty principle. There's a fundamental limit to how precisely we can know certain pairs of physical properties. The more accurately we measure its position, the less accurately we can know its momentum, and vice versa. But wait, it gets weirder. Quantum superposition allows particles to exist in multiple states simultaneously until they're observed. And quantum entanglement? Einstein called it spooky action at a distance. Particles can become linked in such a way that the state of one instantly affects the other, no matter how far apart they are. Imagine you're trying to push a ball up a hill, but you don't have quite enough energy to get it over the top. But in the quantum world, there's a tiny chance the ball could suddenly appear on the other side, as if it had tunneled right through. This quantum tunneling isn't just theoretical. It happens in the real world, crucial for processes like nuclear fusion in stars. Now, the double-slit experiment. We fire particles at a screen with two slits. What we see is an interference pattern made up of individual particle hits. It's as if each particle goes through both slits at once and interferes with itself. But if we try to observe which slit each particle goes through, the interference pattern disappears. Does reality depend on whether we're looking at it or not? So quantum physics is weird and counterintuitive, but is it useful? Absolutely. Enter quantum computing. Classical computers use bits, which can be either 0 or 1. Quantum computers use qubits, which can be 0, 1, or both at the same time. This allows quantum computers to perform certain calculations exponentially faster than classical computers. They could revolutionize fields like cryptography, drug discovery, and complex system modeling. But quantum physics isn't just about future technology, it's already all around us. Lasers, MRI machines, even the GPS in your phone, they all rely on quantum principles. So the next time you use your smartphone or get an MRI, remember, you're experiencing the quantum world in action. We've only scratched the surface of the quantum world. There's still so much we don't understand. Why does the quantum realm behave so differently from the macroscopic world we experience? Is there a deeper theory that can unite quantum mechanics with gravity? These questions drive physicists to continue exploring, pushing the boundaries of our understanding. The quantum world is strange, beautiful, and full of possibilities, and who knows? The next great quantum discovery could change everything, again.